Try to answer the question of why a tree would have a symmetric deposition of circles. For example, if you look here carefully, the center is not in the middle, the branch. It is shifted in a different direction, and the circles or the contours are long in one direction and short in other direction. So how did the tree learn how to make this kind of mechanical structure resist gravity in order to keep the branch from falling? You can say, well, the tree knows how to do it. There has to be a biological way of getting the cells of the tree to know where to deposit the material that make these concentric circles. Look at the circles carefully. They are designed to resist gravity, exactly like your bones. The part of your body that carry your weight is the part that will become thicker. The bones will become thicker depending on the way you use them. Athletes will have heavier bones, and whatever profession you have will determine the shape of your bones, your arms, even your facial expression, your forefront. If you look at a mechanic or a carpenter or a truck driver, the muscles of the face are different from a person who's sitting in an office. The bones are the same thing, the tree is the same thing. So the only way you can figure that out, or you can explain why the tree is not an intelligent human being, but it's an intelligent biochemical system. So it has to have sensors of gravity. The same way you have sensors of gravity on your muscles. When you bend to lift something heavy or something light, how do you know it is heavy or light? Your mind doesn't know it. You cannot say, I'm going to recruit this number of muscle fibers to lift a cup of coffee. And I'm going to recruit this number of muscle fibers to lift a chair. You don't do that. Your mind doesn't do that. So how does it happen? The muscles, they have muscle spindles and the tendon sensors, and there is a feedback mechanism between the muscle cell and the neuron in the spinal cord that recruit certain amount of fibers, muscle fibers, depend on the load that you are going to resist. That simple feedback mechanism where the muscle have to send a signal to the neuron or the brain, and the brain have to determine how many muscle fibers have to be used so you can lift a tire from the ground, a cup of coffee, or a pencil. Some animals have none or all. None or all means the animal can recruit all the muscles or none of the muscles. Like, for example, a chimpanzee can hit you in a way that you can get killed. Why? Because the chimpanzee is not as smart as a human. They cannot do a feedback mechanism to regulate how much force they impact. If you look at chimpanzee or a monkey or a lot of animals, they don't have the sophistication of figuring out how much force they put in their hands or limbs or teeth. They are either deliver all the power or cannot deliver. Well, they can regulate, but not in the way we do. We are very gentle, controlled, sophisticated. Does the tree have sensors that determine which part of the stem, which direction the gravity is increased, which is decreased, so it can send a signal to the DNA. The DNA will determine which cells in what direction will deposit more tissue. That is a question that have to be answered under the microscope and with biochemical analysis and the microscopic X-ray microscope. So you have to figure out what sensors will educate the tree to adjust to the forces of gravity in that directional, sophisticated manner.